Introduction. In mechanical engineering, it is important to study how structures bend and handle stress to make sure they are safe and reliable. Stadium bench are a good example because they carry repeat load and face environmental effect. This study looked at a simple support bench using calculation, simulation, and experiment to check bending and stress. The result helped engineer design bench that are safe, strong, and comfortable for public use.
Uh, my name is Muhammad AQMAL bin Muhammad Arif. This is for the literature review. So first we need to analyze the bench to be a simply supported beam. Okay, so the first step. So to do that, first we need to clarify the support condition, which is the legs. So the legs will be simplified as a pin and roller to support and create a statically determinate system. Next is, so for the crowd, so we model the crowd as a, so if a person is sit on top of the bench, we will model it as a uniformly distributed weight or uniformly distributed load, sorry, across the span. Okay, so if one person sit, it will be a distributed load instead of a point load. So, and we also, for the analysis, we assume that a realistic crowd usually weights around 75 kg per person, okay, sitting. And for the equilibrium equation, we will sum the forces, so all the forces to be equal to 0, and as well as the moment to be equal to 0 to solve for the reaction force, which we will get the reaction force for RA and RB. So next, moving to the analysis theory, we are going to use the Fletcher formula, and we can use this formula to predict the maximum bending stress. So we also need to ensure that the bench doesn't bend when a person sit on it. So we use the double integration method, and by integrating the moment equation twice, we can theoretically derive the slope and the deflection curve when a person will sit on the bench. And then after that, we go for the factor of safety. So we define this as the yield strength of the metal that will divide by our stress, our calculated stress. And if this ratio is greater than 1, so if the FOS factor of safety is more than 1, it is safe. If it's less than 1, it will be considered unsafe.
Hello, my name is HAZIQ, and now I'll be explaining about the methodology. So basically, the methodology consists of how we how we calculate our calculations, basically. So first, we need to find the appropriate geometry and material. We choose structural steel because it's stiff enough or it's strong enough to handle a decent amount of force. And the length, width, and height, we measured the actual length of a bench that could hold up at least 8 people, an average of 8 people. And that's where I go into my second point, loading conditions. We make sure the bench could at least hold up 8 people with an average weight of 75 kilograms. So basically, the bench will be the load condition of the bench will be a uniformly distributed load with rollers. Basically, there's 2 reactions, one at point A and another one at point B. Now, for my third point are the internal forces. So basically, we need to calculate the maximum bending stress, maximum bending moment and second moment of area. Now I'll be continuing with my methodology. Now, stress and deflection. So basically, we need to, as I said, we need to measure all the forces acting upon the bench. Now, why we have to measure all those forces is because, number one, we need to ensure comfort. So basically, the bench might be strong enough to not break, but if it bends 10 centimeters when someone sits on it, then it's a bad design. So the maximum deflection we could measure using the formula in order to reduce the sag without necessarily adding more weight. And also, number 2 is to optimize shape and cost. Without all these calculations that we did to measure the forces acting on the beam or on the bench, basically, we would have over-engineered the bench by using excessively thick materials, which will increase the cost and also make it heavier in the process. So we measure all the variables in order to cut as much cost as possible and make the bench as light as possible. And also, the third point, which leads me to my third point, is to predict the material failure. So basically, the primary reason or the main reason that we calculate the maximum bending moment and the second moment of inertia is to determine the maximum bending stress the material will experience. So basically, we need to ensure that the yield strength the stress doesn't exceed the yield strength, so it won't fail or permanently deform or break. So then we can measure the factor of safety to ensure that our bench is as safe as possible.
Assalamualaikum, my name is Muhammad TAUFIK, my ZAMANI. My metric number is CD240229. Today I will present about calculation. The mesh that we use, that is stadium mesh. The mesh geometry is the length is 4.1148 meter. For the mesh width, that is 0.3048 meter, and mesh height is 0.06 meter. For the material properties that we use, that is structural steel, the yang modulus is 200 Pascal and the shear Y is 240 MPa, 250 MPa. For the loading, we assume that the one people weight is 75 kilogram, and we assume that one batch can afford 8 people. For the weight formula, that we need to use an mg, that n stand for people, that is 8 people, and the mass, that is 75 kilo, and g as gravity is 9.81, and we get 5.5886 Newton. For the W, we use W over L, that we get 1430.6 Newton meter. For the support reaction, simply supported, the formula is RA over RB over WL over 2, that we get 2943 Newton. For the maximum bending moment, and max, we use WL2 over 8, that we get 3025.4 Newton meter. For the section properties, for this mesh, we use square formula, that is I VH3 over 12, that we get 5.449 and 4. For the C, we need to divide head over 2, that we get 0.03 meter. For the maximum bending stress, shear max, the formula is MC over I, that we get 16.5 MPa. For the maximum deflection, shear max, the formula is 5WL4 over 384 EI, that we get 4.8 millimeter. Okay, for the result, we got span length, that is L, got 4.1148 meter, and the uniformly distributed load W, we got 1430.6 Newton meter, and for the maximum reaction force, we got 2943 Newton, maximum bending moment 3025.4 Newton meter, maximum bending stress 16.5 megapascal, and maximum deflection 4.8 millimeter. And lastly, for the factor of safety, FOS, we got 15.15, that is over 1. For the structural status, it is safe for 8 to 10 occupants because the FOS is higher than 1, and the calculation said that it is still safe even though
it carries 10 people. This is graph for the maximum shear and bending moment. As we see, the result is same with the calculation that it show that calculation and graph is stabilized and true.
Hi and Assalamualaikum. My name is Muhammad Arif. My metric number DD240102. So, we'll talk about the discussion of the project. First, stress analysis and safety verification. For the max stress, calculated at 16.5 megapascal. For the yield strength, structural steel limit is 250 megapascal. And for the safety factor, high factor of safety of 50.15. For the design verdict, the bench is structurally safe but likely over-engineered, which standard furniture usually require an FOS between 2.4 and 4.0. So for the deflection analysis, actual deflection only 4.8 mm over the 4 meter span. Allowable limit is 11.43 mm based on standard L per 360 limit. For the conclusion, the bench is very rigid and will not sag noticeably under load. For the third and last, validation of assumption, which is the loading model as a uniformly distributed load UDL rather than individual people. This is safe, conservative estimate. For the support, idealized as simply supported, which is pin, which predict higher stress than the actual real world connection. For dynamic loads, jumping or dropping heavy item was not calculated, but the high safety factor 15.15 easily cover this risk. Thank you.
For conclusion, the simple support stadium bench is a safe, strong and stable, with stress and deflection within acceptable limit, making it suitable for public use while meeting basic requirements of safety, comfort and survivability. For the recommendation, number one is use hollow section or optimize cross section to reduce material and weight. Number two is explore different support conditions to reflect real use. Number three is consider dynamic load from people moving on the bench. Number four is improve design efficiency while keeping safety and comfort.